Hello friends, welcome back to my channel Engineering Mathematics DJ Ganit. In this lecture we are going to discuss one question about binomial probability distribution. This question was asked in GTU Summer 2022 exam for 7 marks. So first we understand what is this question. Define binomial distribution. That is, we have to write down the definition for binomial distribution. We have already discussed about definition of binomial distribution in lecture number 1 on binomial distribution. So if you have not seen those lectures number 1 to 8, I suggest you to watch those lectures first and then go for this lecture number 9. Now the problem is, a particular telephone number is used to receive both voice calls and fax messages. Suppose that 25% of the incoming calls involve fax messages and consider a sample of 10 incoming calls. What is the probability that at most 3, exactly 3, at least 3 and more than 3 of the incoming calls involve a fax message? So here it is given that a particular telephone number is used to receive both voice calls and fax messages, and out of the total incoming calls, 25% incoming calls involve fax messages. So if we consider the event that particular incoming call involves a fax message, then probability for that event is 25 divided by 100, that is 0.25, and they are taking a sample of n equal to 10 incoming calls, and out of these 10 incoming calls we have to answer these questions, that out of these 10 incoming calls, what is the probability that at most 3 calls involve a fax message. Similarly, what is the probability that exactly 3 calls involve a fax message, and so on. Now if you think that if we want to apply binomial distribution, then our random experiment under consideration must satisfy 4 conditions. That is, first condition is the number of trials must be finite. Here they are checking for 10 incoming calls, so number of trials are 10, which is finite. Now for each incoming call they are checking that whether that incoming call involves a fax message or not. So it is clear or obvious that these n trials are independent, or we can assume that there is nothing to do with every trial, that it does not depend that one trial involve a fax message, or if we consider the event that trial 1 involve a fax message, then that event is not dependent on remaining trials involving a fax message. So we can say that these trials are independent. Now for each trial there are only 2 possibilities, whether that trial involves a fax message or that trial does not involve a fax message. That means there are only 2 possible outcomes for each trial, and it is given that that 25% of the incoming calls involve a fax message. So the probability of incoming call involving a fax message is 0.25, and it is constant for each trial. So all the conditions of binomial random experiment are satisfied. Therefore we can say that this random experiment is or random experiment follows a binomial probability distribution, and we can use the formula for binomial probability distribution to find out all these required probabilities. So first I have to define what is the random variable under consideration. So we will consider random variable x equal to number of calls involving a fax message, number of calls involving a fax message, and they are taking sample of 10 incoming calls. So the possible values of incoming calls involving a fax message are 0, 1, 2, 3 up to 10, because there are 10 incoming calls. So there are different possibilities that no incoming call involve a fax message, only one incoming call involves a fax message. Similarly, all these are possible values of this random variable capital X. And we can consider success as, we can consider the event that incoming call involve a fax message. Suppose we consider the event incoming call involves a fax message. If we consider this event as success, then it is given that probability is 25% that incoming call involve fax messages. So probability of success is given as P equal to 0.25, and we are familiar with the probability mass function of binomial distribution. If we are interested in the probability of small x successes out of total n trials, then probability that there are x successes among n trials is given by NCX p raised to x 1 minus p raised to n minus x. X takes the values 0, 1, 2 up to n, and here success is incoming call involves a fax message. So this gives us the probability of x incoming calls involving a fax message. If we want to find out that at least, or if we want to find out that exactly 3 incoming calls involve a fax message, probability that x equal to 3. So this gives the probability that exactly 3 incoming calls involve a fax message, so that we can obtain easily using this formula. So all we have to understand here is that this is the problem of binomial probability distribution, and here random variable is number of calls involving a fax message, that we can decide from this question. We are asked to find out the probability that at most 3 calls involve a fax message, exactly 3 calls involve a fax message. So from this we can have the idea that we have to consider random variable x as number of calls involving a fax message, and from that we have the idea that we will consider success as the event that incoming call involves a fax message, and we are given the probability of success which is 25%. So P is 0.25, 1 minus P will be equal to 1 minus 0.25, that is 0.75, and value of n is 10. So using this formula for probability mass function, I have calculated all these probabilities. So we have to write systematically. First we have written the definition for binomial distribution. The discrete probability distribution whose probability mass function is given by this formula is known as binomial distribution, and we have to write systematically. For given problem, we consider random variable x equal to the number of calls involving a fax message, and here sample size is 10. There are 10 incoming calls for which we have to check whether they involve fax messages or not. Then the possible values of random variable x are 0, 1, 2 up to 10, and we consider success as the event that a call involves a fax message, and given that probability of success is 25%, that is 0.25, and therefore given random variable is a binomial random variable. We have discussed that all the conditions are satisfied. So this is a binomial random variable, and its probability mass function is having this ready-made formula. If our random variable is binomial random variable, its probability mass function is given by probability that capital X equal to small x equal to NCx p raised to x 1 minus p raised to n minus x, and here we take n equal to 10, p equal to 0.25, 1 minus p will be 0.75 and n is replaced by 10. So we have this probability that X incoming calls involve a fax message, which gives the probability of X calls involving a fax message. Now in first part we are asked to find that probability of at most 3 calls involving a fax message. At most 3 means less than or equal to 3. So the possible values are 0, 1, 2 and 3. So we are asked to find the probability that at most 3 calls involve a fax message, that is probability that capital X is less than or equal to 3, that is equal to probability that X equal to 0 plus probability that X equal to 1 plus probability that X equal to 2 and probability that X equal to 3. So that I have written here probability of at most 3 calls involve a fax message equal to probability that capital X is less than or equal to 3. That means we have to add probabilities up to X equal to 0, 1, 2 and 3, and that we can obtain from this by taking X equal to 0, 1, 2 and 3. So I have substituted X values here and I obtain these 4 terms. This is for small x equal to 0, this is for small x equal to 1, and using scientific calculator I find that this probability is 0.7755. Probability that at most 3 calls involve a fax message is 0.7755. Now this we have obtained using this formula for probability mass function. If we wish, we can use binomial probability table also to find out this value, probability that capital X is less than or equal to 3. So for that I have to use binomial probability table with here value of n is 10, probability of success is 0.25, and if we compare this probability that X is less than or equal to 3 with X is less than or equal to small x, then value of X is 3. So we have to search for these values, n equal to 10, p equal to 0.25 and X equal to 3 in the cumulative binomial probability table. These are the cumulative binomial probabilities, that is probability that capital X is less than or equal to small x. So here our X is 3, n is 10 and probability of success is 0.25 and n is 10. So first we concentrate on n equal to 10, probability of success is 0.25 and value of X is 3. So I have to search at the intersection of this row and this column. This column for probability of success 0.25, this is for small x equal to 3, and here we can see we have 0.776, that is probability that capital X is less than or equal to 3 is 0.776 using cumulative binomial probability table. So if we are having probability tables, then we can directly write down that probability that capital X is less than or equal to 3 is 0.776, and in the bracket we can mention that using binomial table with n equal to 10, p equal to 0.25 and X equal to 3. So this is first part of the problem. We are asked to find the probability that at most 3 calls involve a fax message. Second probability is exactly 3 calls involve a fax message, so that we can obtain simply by taking small x equal to 3 in the formula which we have written for probability mass function of this random variable. So here we can take small x equal to 3 and we can easily obtain the probability that exactly 3 calls involve a fax message. So that is 10C3.25 raised to 3.75 raised to 7, and after doing calculations we obtain this 0.2502825, or we can round off up to 3 or 4 decimal places. Suppose we go up to this decimal place, then because this digit is greater than 5, I round off this as 3. Now if we don't want to use this probability mass function formula, again we can use the table. We can write probability that capital X equal to 3 as probability that capital X is less than or equal to 3 minus probability that capital X is less than or equal to 2. This is the sum of probabilities starting from 0 up to 3. This is the sum of probabilities starting from 0 up to 2. So if we subtract probabilities starting from 0 up to 2 from this probability starting from 0 up to 3, then we will obtain this probability. This we can obtain using cumulative binomial probability table with small x equal to 3 and small x equal to 2, and n is fixed 10, p equal to 0.25. This we have already obtained in above step. Probability that x is less than or equal to 3 is 0.776, and this we can again obtain from the table. P is 0.25, and now I have to search for small x equal to 2, so I have to go in this row, and here I have to search in this column, and at the intersection we have 0.526 for small x equal to 2, so this is 0.526. So we can use binomial probability table also. Probability that capital X equal to 3 equal to probability that capital X is less than or equal to 3 minus probability that capital X is less than or equal to 2, and these two we have obtained using binomial probability table, and we find that answer is 0.250, and we can compare both the answers. This is using binomial probability mass function. This we have obtained using this formula by taking x equal to 3, and this we have obtained using binomial table, and answers are same up to 3 decimal places. So that is our choice whether we want to use calculator or we can use binomial table also. Third one is probability of at least 3 calls involving a fax message. So this means capital X must be greater than or equal to 3. At least 3 means 3 or more calls. So we have to find out probability that capital X is greater than or equal to 3. So this we can calculate in this way. Probability starting from x equal to 3 up to x equal to 10, or we can use the concept of complementary event. The complementary event of capital X greater than or equal to 3 is capital X is less than 3, or we can say that capital X is less than or equal to 2, because x is a discrete random variable. So we can find out this easily. Here we have obtained also probability that capital X is less than or equal to 2, so we can substitute it and we can find out this probability. Probability that at least 3 calls involve a fax message equal to probability that capital X is greater than or equal to 3. This is equal to 1 minus probability that x is less than 3, because x less than 3 and x is greater than or equal to 3 are complementary events. We have to mention here these events are complementary events, and this is equivalent to 1 minus probability that capital X is less than or equal to 2, and I have this probability x is less than or equal to 2 is 0.526, so I have written here. So in this way we can obtain this. Other way is, first we write this as 1 minus probability that x is less than 3, and this I can write as probability that x is less than 3 can be written as probability that x is less than or equal to 3 minus probability that x equal to 3. So this will give you this probability x is less than or equal to 2. These are the probabilities starting from 0 up to 3, and we are subtracting probability that x equal to 3. So we are left with these probabilities from 0 to 2, and we are having these two values we have calculated here. Probability that x is less than or equal to 3 is 0.776, and for x equal to 3 it is 0.250. So that we can substitute and we obtain the same answer. So this is another way of doing the same thing. Otherwise this is okay. This is very straightforward. Okay. This is just to explain that we can find out the same probability in another way also. And last one is probability that more than 3 calls involve a fax message. That is probability that capital X is greater than 3, and here also we can use the concept of complementary event. X is greater than 3 and x is less than or equal to 3 are complementary events, and probability of x less than or equal to 3 is 0.776. So that we substitute and we find this probability as 0.224. So this is simple question for binomial probability distribution, and it was asked for 7 marks. And if we are familiar with the formula of binomial probability mass function, we can easily find out this type of binomial probabilities. One thing we should be clear is that we cannot apply binomial probability distribution every time. We have to check 4 conditions. First condition is number of trials are finite. Second condition is trials are independent. Third condition is there are only 2 outcomes for each trial, and the fourth one is probability of success is constant for each trial. If these 4 conditions are satisfied, then our random experiment is binomial random experiment, and we can use binomial probability mass function formula to obtain the required probabilities. And so this is all about this session. I hope you like it. Keep watching. Thank you.